Greetings, this is Mr. Caslin. Let's look at a problem we were looking at last week. We hadn't practiced a lot with condensing and expanding logs, but if you've had a chance to work a bunch of those problems, then this problem should be okay. What happened when we were working it is, remember, you're going to condense a subtraction into a division. You can also condense this part here, an addition, into a multiplication. So I was looking at that form first. I condensed it into a multiplication first and then into a division. And we weren't getting the answer exactly the way the answer key had it. So we're going to work it the division first, and we're going to find out it's going to match exact when we work it from left to right. Now, the first thing I usually do in a condense logarithm is take your multipliers out in front of your logs, or in this case your natural log, and put it back as an exponent, because we do have a property that says that those are equivalent. Now, when you do an exponent to a fraction, what I'm going to do is we have an exponent property that says you're allowed to distribute that power of 2 to both the numerator and denominator. Okay, so I'm going to do both those things in one step. I'm going to make it an exponent and then distribute that exponent to numerator and denominator. Okay, nothing changes in these yet. Okay, I've got the natural log of x times z minus the natural log of x times the square root of y. Okay, so I've just executed that one property. Now, let's condense these. Remember, a subtraction is going to become a division. We're condensing it into one natural log of x times z over x times the square root of y. Okay, plus, I'm just going to bring this one down, plus the natural log of y squared z squared. Okay, all we're doing is condensing. Notice you have, these are all multiplied. You've got an x divided by x, which is the same as 1. So basically, think of those as canceling out. Okay, so now you have two natural logs that are added. When you condense these together, you're going to condense them into a multiplication. So you have the natural log of, when you multiply two fractions, you just multiply across. You've got z times y squared, and multiplication is commutative, so I'm going to change the order here. I'm going to say z squared times the square root of y. Okay, we're almost there. Now we've condensed these fractions into one, or we've condensed these natural logs into one natural log. Now it's just simplify our fraction. Okay, kind of have to remember your exponent properties on this. You've got a z divided by z squared. Remember, when you're dividing exponents, that's really z to the first divided by z squared. It becomes z to the negative 1. Okay, 1 minus 2 is negative 1. We don't like negative exponents, so we flip it back down into the denominator. So all we have left is a z in our denominator. Okay, the shortcut way is to say you have a z to the first, z to the second, which one's larger? Z to the second, how much is it larger by? It's larger by z to the first. It's in the denominator. Okay, second of all, we have a y squared in the numerator. And what I'm going to do is I'm going to change the square root into a fractional exponent. Remember, that's the same as y to the 1/2. Okay, so I've got division. I'm going to subtract our exponents. 2 minus 1/2, which is the same as 4 over 2 minus 1/2. 4 over 2 minus 1 over 2 is 3 over 2. I've got y to the 3 over 2 divided by z, which I believe is what you had in your answer key. Okay, so it's the same exponent properties, just a lot of, the tricky part about this is you've got a square root in it, you've got some fractional exponents, you've got a subtraction and a addition. But if you need to, watch this video a couple times, just go through your logical process, use your properties, and it should be fine. Now, ask your instructor, do you want the answer in this final answer, or do they should you put it as a radical? Remember, y to the 3/2 is the same as the square root of y to the 3rd over z. Okay, that's a y to the 3rd. Good. All right, so these two answers are equivalent. They're just different. One's a fractional exponent, and one is in radical form. Okay, logarithms are fairly new, so just keep practicing them. And you haven't seen these in your other algebra classes, so they're kind of new. So it just takes a little more practice to get used to them. And good luck.